What's up, guys? Today we're going to be doing section 2.2 and 2.3. What's it on? It's on equations. That's right, equations. Equations. Equa. That's right, equations have equal signs, right? Expressions don't have equal signs, equations do. Anyway, let's get started on this lesson. So why the heck was I walking around my whole house? I don't know. I just felt like we were going somewhere, and we are going somewhere. We're going to be able to solve equations, and that's a big deal in Algebra 1. So anyways, let's take a look at this part of our notes right here, 2.2, solving 1 and 2-step equations. Up until this point, we've only been simplifying expressions. We don't have an equal sign, right? I mean, if we take a look at this, we have 2x plus 3 minus 5x. There is no equal sign, okay? And what could we do with expressions? Because this is an expression. Let's underline that. What could we do with expressions? We can simplify them. We can simplify them. Now, what does simplify actually mean? Let me write this down. Simplify means distributive property and combining like terms. It's both. And of course, you do distributive property first because that's really the distribution of multiplication. And then you do combining like terms because that's really adding and subtracting. So anyway, the only thing we could do here is simplify, which means we're going to combine the 2x with the minus 5x and get negative 3x. And the plus 3, you just bring it down, and that's all you could do. You used to have 3 terms, 1, 2, 3. You have simplified it. Now there's only 2 terms. You cannot combine letters with numbers. Anyway, now we're not going to be, well, we're still going to be dealing with expressions. We're still going to be simplifying expressions. But now we're going to start solving equations. So we first have to understand what an equation is. Well, an equation is like a scale. Okay, it says right here, an equation is like a balanced scale. Whatever you do to one side, you must do to the other. Okay, and the goal of solving any equation is to get x by itself on one side. And how do you do that? If you want to get rid of something, you must do the opposite, the inverse operation. So let's get a visual so we can really understand what an equation is. Ladies and gentlemen, right here we have a scale, and as you can see, we have some marbles here, or whatever you want to call them, and a red rectangular box. And as you can see, it's perfectly balanced, right? It's perfectly balanced. So I could put an equal sign because the weight is equal. If it were unbalanced, then like it'd be like up here, down there. So, but it's perfectly balanced. This weight equals this weight. That's why I put that equal sign right between them. Anyhow, what if I were to take this guy and remove it? Then it would go off balance. This would go down because it's heavier. So what I'm going to do is, in order to maintain, I'm sorry about that. In order to maintain equality, in order to maintain that equal sign, what I'm going to do is I'm going to remove one of these, but I'm also going to remove one of these. That way, it remains equal. The weight is still equal. This weight is equal to that weight, okay? And again, I could do something else. I could remove this guy right here and move this guy at the same time, remove both of them, and again, I still have equal weight on both sides. So the first thing you want to recognize is that an equation, equal, that means equal sign, this equal sign right here, you could do anything you want to an equation, as long as what you do to one side, you must do to the other. So as you can see, I removed these two from this side, and I removed these two from this side, so the equation remains true. It's still equal on both sides. But it's not just about removing. I could also add things on there, right? I could add this one here, as long as I add this one over here at the same time, and it'll remain equal. Right? Or then again, I could take this one off, as long as I take this one off, and it'll remain equal. Okay? So let's go back to putting this one here and that one there, and this one over here and that one over there. Okay? So what do we have here? We have an equation. What does the equation say? Let's call this red rectangle X. Okay? Let me actually label it X. Okay? And let's just call these blue marbles, let's call them numbers, all right? So what do we have? How many numbers do we have on this side? We have 1, 2, 3, 4, 5, 6, 7. So we really have 7 on the left side equals, and we have x plus 2 on the right side. We have the letter x, the variable x, and 2 more numbers on the right side. So we really have x plus 2 on the right side. So this is our equation, 7 equals x plus 2. And what we want to do, as we read in the notes that you have in front of you, or in the previous slide, it says that our goal to solving any equation is to get x by itself on one side. Now, what am I talking about sides? The equal sign is what separates the two sides of the equation. So our goal is to get x by itself. I want to get rid of this plus 2. How do I do that? I'm going to do the opposite. So what is the opposite of plus 2? It's minus 2. So I'm going to go minus 2 here. As long as I go minus 2 over here, it'll remain balanced, okay? So if I do a minus 2 here, it's going to be gone. It's just going to be x. Let me visually show you that I pull off both of those. Minus 2 there. And remember, what you do to one side, if you subtract the 2 here, you got to subtract 2 over here. You're going to do to the other side. So if you subtract 2, you're going to have 5 left over on this side. Let me show you by removing those 2. Whatever you do to one side, do to the other. So I remove 2 from here, I remove 2 from here, it remains equal. So what do we have now? We have x equals 1, 2, 3, 4, 5. And that's exactly our answer. X equals 5. X equals 5. I hope that helps to give you the visual of what an equation is like. So let me clean this up a bit and let me reset it. Check this out. So let's check this out here. Let's actually write down what this equation would look like algebraically, what this visual looks like algebraically. On the left side, we have one of these x's and 1, 2, 3, 4, 5, 6, 7, 8. So there's our kind of algebraic expression. That's one of these red boxes plus 8 of these blue marbles. On the right side, we have 2 of those x's and 3 of these blue marbles. And of course, let's not forget about this big giant equal sign that's saying that it's perfectly balanced. So let's write down the equal sign and then write down 2 x's plus 3 marbles. So there we go. And this is actually still not the algebraic equation I want. Let me just call these 8 marbles, let me just call it the number 8. And instead of the rectangular red box, let me actually put the variable x that we're going to be using. So this is our actual equation without the boxes or the marbles. And this is way harder than what we're doing this whole week, all right? If you understand this right here, you're going to be able to ace the quiz Friday. Because right here we actually have variable on the left side of the equal sign and a variable on the right side of the equal sign. So we have variables on both sides, okay? So I don't want variables on both sides. If we take a look at the notes on solving equations, it says an equation's like a balance. Whatever you do to one side, you must do to the other. The goal of solving any equation is to get x by itself on one side. You could also say isolate the variable. But isolate the variable means get x by itself on one side. So how do you do that? If you want to get rid of something, you must do the opposite, the inverse operation. And remember, whatever you do to one side, you must do to the other. So if you want to get rid of something, you do the opposite of it. If there's a fire, you're going to turn it off with water, the opposite, right? So right here, we have x's on both sides. And the goal is to get x by itself on one side. So you don't want an x here and an x over here. You want to get rid of one of those x's. So let's get rid of this x right here. And again, how do you get rid of something? You do the opposite. So the opposite of positive x is negative x. And that'll cancel it out. What did I just do? I removed this x. I removed it. Right? But if I remove an x on the left side, I have to remove an x on the right side to maintain the balance. So I need to also remove an x from this side so that the equality of the weights stay the same. So I need to remove an x on this side as well. So I'm going to subtract x over here. And I have a new equation if I rewrite everything. Just like before, do one step, rewrite everything. I have a positive 8, I have equals, and I have 1x, because 2x take away 1x is 1x, plus 3. That's our new equation. Now I still want to get the x by itself. Here's the x. It's not by itself. There's a plus 3 right there. How do you get rid of the plus 3? Anybody awake? Subtract 3, take away 3, minus 3. And what you do to one side, you do to the other side to maintain the balance. So if I did remove 3 from both sides, 1, 2, 3, and remove 3, 1, 2, 3, I have my final answer. And my final answer is x equals, of course, I could put a 1 right here if I wanted to, but I'm not going to do that because 1x is simply x. So we really have, x equals 5. And that is your answer. Now, what does that actually mean in terms of this visual? That this little red container, how much does it actually weigh compared to marbles? 5 marbles, right? So let's jump to this handout that we have. And right here we have the steps to solving any equation. Emphasis on any. All right, we're going to have some crazy equations next week and the following week and a month from now. And in Algebra 2, we're going to have some crazy equations. And these are the steps to solving any equation. All right, so step 1 is to simplify both sides of the equation. You guys remember what simplify means? Simplify means distributive property and combining like terms, right? And that's what it says down here, distributive property and combining like terms. You're always going to distribute before combining. So that's step 1. Step 2 is to isolate the variable on one side. That means get x by itself on one side. And remember, what you do to one side, you must do to the other. And also remember that to get rid of something, you do the opposite, right? And notice down here, it says all of the equations on this section will already be simplified. So you don't even have to do step 1. All we're going to be worried about is getting x by itself on one side. So if it's not by itself, you're going to get it by itself by doing the opposite of whatever's there and doing it to both sides. So let's jump down here. We have several examples, and the explanation is already right next to it of what we're going to be doing. But let's start out by saying, where's x at? Is it on the left side of the equal sign or on the right side of the equal sign? Where is it? It's on the left. Is it by itself on the left side? No, there's a +3 right there. So how do you get rid of the +3? -3, the opposite, right? If there's a fire, you turn it off with water, with the opposite. So, and let me tell you this, I like doing the -3 right below it. Now, I've seen the textbook, especially, they do the -3. It's weird. They'll do it, let me erase mine just for a little while. They'll do the -3 out here in the front and put a -3 out here in the back. It's the same thing, right? I like to do it below because I think it's a little more organized. I mean, at least for me. If you like writing it on the side, go for it. But I like going below. I like to put a -3 right below the +3 so you could see it cancel, and a -3 over here. And what do you do with the x? You bring it down. What do you do with the equal sign? You bring it down, and 11 take away 3 is 8. So that's your final answer. Let's jump to the next example. On this one, we have -3. What's happening between the -3 and the x? Multiplication, right? So if you want to get rid of the multiplication of -3, you have to do the opposite of multiplying. What's the opposite of multiplying? Dividing. So you're actually going to do a fraction bar, which is a division bar, and divide by that same exact value, okay? So the opposite of multiplying by -3 is dividing by -3. And what you do to one side, you do to the other side again to maintain the balance. So the -3's cancel out, the x comes down, the equal sign comes down, and then it goes back to knowing how to divide and multiply and add and subtract integers. 12 divided by -3, what's the answer? -4. A positive divided by a negative is a negative. Let's move on. This one down here is actually a 2-step equation, all right? On today's homework, we're only doing 1-step equations. Well, we might as well jump into this one. Here's the x. This is what you want by itself. It's on the left side of the equal sign. Is it by itself? It's not by itself. You have a -2 right in front of it and a -5 over here. So the question is, which one do you get rid of first? The -5. It's kind of like this. X is the movie star or the rock star, the popular person, whatever. And this is the movie star's buddy. It's pretty cool to hang out even with the movie star's buddy. But this guy's a bum at the corner all by himself, the loner. You don't care about the loner. Let's get rid of that guy first. So the opposite of -5 is +5. That cancels out. What you do to one side, you do to the other side to maintain the balance. You're going to end up with 18 on this side. The equal sign is going to come down. And on the left side, you're going to have -2x. And then we go to get rid of the -2 in front of the x. Now, it does not say x minus 2. What does it actually say? It says -2 times x. So you got to recognize what operation is happening so you could actually do the opposite of that operation. So I'm going to be dividing by -2. That'll cancel out. What I do to one side, I do to the other. I'm dividing by -2. I get my final answer. The x comes down, the equals comes down, and I get 18 divided by -2. That answer is -9. That's my final answer. Time ran out.